Good morning, sir.
Morning, sir.
Good morning, sir.
Morning, sir.
सर सर मंडे को हमारी क्लास होगी?
ऑनलाइन होगा मंडे को।
गुड मॉर्निंग सर।
मंडे को किसका क्लास होगी पता नहीं, मगर मंडे को क्लासेस रहेंगे, वो ऑनलाइन ही रहेंगे। 1 तारीख से लगा हुआ है।
हाँ सर, 1 तारीख की उल्टे
टुडे
सर तो आज लास्ट लेक्चर
इफेक्टिवली
मंडे को भी हो सकता है आपका लेक्चर, बट
मंडे को
आज
भी
लेक्चर होगा हमारे साथ यार। सर बहुत अजीब लगेगा कि आप फिजिक्स नहीं पढ़ा रहे होंगे तो।
सर बहुत बड़ा सदमा लगेगा वो फर्स्ट मार्च से।
what is interesting is few days back we were learning kinematics, right?
हाँ सर, ऐसा लग रहा
हाँ
है।
सर।
Yes, sir.
अभी
This 1 year moved so fast. Believe me, next 6 months will move much faster.
सर मत डर।
आप blink करोगे टाइम हो जाएगा। This part of your life is the fastest moving part of your life. After that, life again will become slow. Even before you realize, you are sitting in front of the screen for the JEE entrance examination. Time moves so fast in these two years because that's the quantity of the content that is moving. You lose a track of time. When will you feel time is going slow? When you are relaxed, when you are bored. You had so much of a job, and your job will be Herculean in the next 6 months. Right?
सर ऐसा लग रहा है आप आज कैट एंड डॉग प्रॉब्लम कराने वाले हो काइनेमेटिक्स।
नहीं नहीं, but one good thing for teachers, as it is my personal opinion, during the pandemic time the others had to either sit at home or go to the workplace to work. Sitting idle is very difficult. Empty head is devil's workshop. कब तक टीवी देखोगे, कब तक यूट्यूब देखोगे, कब तक न्यूज देखोगे। Teaching my biggest advantage was all throughout the pandemic the teachers were engaged. Empty head is devil's workshop. We had something on which we could bank on. We were not very comfortable with Zoom lectures. It had its own share of trouble, spammers, everything, but ultimately we had a schedule. We had a work at our hand. Having work at hand is a blessing in disguise always. Whenever we are in deep distress, keep working. That relieves you of stress. I read out the quotation for you people, right? God created man to work.
Yes.
Even in the worst of the situations like the pandemic, teachers were regularly working. This is a blessing for them. It's an advantage. They were kept continuously engaged. Remaining all people were sending WhatsApp jokes on pandemic. घर में बैठ के count the number of grains in rice. All these funny jokes were being designed and sent. Teachers were busy working.
Sir, after some time they suicide also. Most of. सर 2-3 लोग ने तो किया था ना पैंडेमिक के कारण।
There is depression. They should have been diagnosed and treated. There is depression. Human by nature. Empty head, खाली बैठ के आदमी सोचेगा. Wrong thoughts come. So keep working. That way teachers were blessed. I personally feel that 2 years of the pandemic, exactly March 2 years back, the pandemic started for us. 2 years of the pandemic, Zoom, thanks to Zoom lectures, we could keep ourselves engaged. And effectively, I think if Monday we don't have a class, this will be effectively the last Zoom lectures with this batch as it is. We will have Zoom lectures. Mumbai has a strange problem. During rainy season, every year, at least once or twice, we have to cancel the classes because there will be waterlogging.
Yes, sir.
So during those times in rainy season when there is a heavy rain expected, we will make it Zoom lecture. But then the batch will be
Zoom भी
different.
चलना चाहिए ना बाद में. Network issue might happen due to the rain.
Pardon?
So network issues might happen due to the rain, so people can't attend those classes as well.
What is this guy saying here? I'm unable to hear.
Network issue
सर
for
ये
rainy
network issue की
season.
वजह से इंटरनेट इशू भी आएगा ना.
नहीं उतना ज्यादा भी नेटवर्क थोड़ा लैग होगा तो मे बी एक लेक्चर कैंसिल होगा आधा घंटा. Somehow it will not be completely cancelled.
So
You
it's
can
on the
at least-
online days, the batch will be combined again for the Zoom lecture.
No, those batches will, the timetable will be the same. Instead of going there, if ever there's an emergency like heavy rain, waterlogging, whatever timetable we have, we'll have the same timetable. We will make new groups, right? WhatsApp, we'll send the link in that particular.
Yeah, so on the online days, like Andheri will have different classes, Borivali different like that.
तो बोरीवली में जो फैकल्टी है वो वहां का ऑनलाइन ले लेगा. अंधेरी में जो फैकल्टी है अंधेरी का ऑनलाइन ले. जो लेक्चर फैकल्टी क्लास जाकर लेगा वही ऑनलाइन ले लेगा. दिक्कत क्या है?
बट आपका टाइम टेबल आ गया.
नहीं आए नहीं, आ जाएगा.
इतना स्लो
अगर आ
क्यों
गया
है?
तो मुझे पता चल जाता मंडे हमारी क्लास है कि नहीं.
हाँ सर वो पता चल जाएगा. तो मंडे को ऑनलाइन है.
मंडे को रहेगा तो ऑनलाइन 1 तारीख से, बिकॉज क्वाइट अ फ्यू फैकल्टी आर ट्रैवलिंग फ्रॉम देयर नेटिव प्लेसेस.
हाँ सर बताया था.
So there'll be some will reach on Monday, some will reach on Sunday. So I don't think Monday they can make it offline. Some centers they may try, but overall I think it's from first on.
So
Fine.
we will miss.
We will miss you जो आप नहीं पढ़ाओगे जिसको.
I will also be missing you. It is the same here.
सर वो
बिटकॉइन किसको देंगे सर?
तो ड्रम
हाँ,
वाली
सर.
आवाज मिस करेंगे सर.
So somewhere down the lane, either in revision lectures or otherwise through before the JE, I'll be seeing you people either way. May it be Chembur, may it be Nerul, or may it be Thane. So don't worry about it.
Thank
We
you,
will
sir.
meet. I'll come down. So we will meet. Nothing to worry. Bas. What was the last thing we covered in the
Sir,
previous?
rolling.
Sir, rolling.
rolling.
To
Scrolling.
introduce
Energy of
rolling.
a day.
Rolling was continuous toppling दिखाया मैंने, right?
Yes, sir.
Yes.
आपने समझाया.
Cycle wheel दिखाया आपको.
हाँ सर बाइसिकल व्हील दिखा कि नीचे का स्पोक्स व्हील शो ऊपर का विजिबल.
हाँ, yeah, that is.
Yes, sir.
Let's see.
Yes, sir. और
Electric
उसमें
electric वाला
kinetic
photo.
energy of a disk कराया था.
Kinetic energy से we justified, right?
Yes, sir. That was the last thing.
Okay. Kinetic energy पे there's one more small thing. A small cheap trick played. This is a hollow sphere. This is a hollow sphere which is rolling. VCM omega. This is M. Mass of the hollow sphere is M. Mass of the hollow sphere is M. And there is liquid inside of mass and not. Non-viscous liquid. Non-viscous liquid of mass and non-viscous liquid.
Sir, it is completely filled.
Yeah. Non-viscous liquid of mass and not completely filled. Now they ask for the kinetic energy of this system. They do this intentionally. Chapter's name is Rigid Body Dynamics. Chapter's name is
Rigid body.
Rigid body dynamics.
in this rigid body dynamics. This outer body is rigid. The liquid inside is not rigid.
Yes, sir.
And there is no viscosity. One layer doesn't drag the other layer. So whole of the liquid will have only translational kinetic energy. Kinetic energy of the liquid plus kinetic energy of hollow sphere. Kinetic energy of the liquid, kinetic energy of the hollow sphere. Kinetic energy of the liquid is half m naught VCM squared. That's all. That's all. Liquid has only translational energy. Why the liquid rotate? Kinetic energy of the hollow sphere is half ICM omega squared plus half m VCM squared. Hollow sphere is rolling. Hollow sphere is rolling. It's given. So kinetic energy of the body about its central mass plus kinetic energy of central mass half m naught VCM squared. Hollow sphere's moment of inertia.
2/3 mr square.
2
by 3 mr.
No.
2 by 3 mr square. You're right. Omega square will be v square by r square. क्यों भाई साहब?
V is equal to omega r.
Condition for rolling, VCM is equal to r omega.
Yes, sir.
Half m naught VCM square. So m VCM square by 3 plus m VCM square by 2. This is the kinetic energy of the hollow sphere, kinetic energy of the liquid. Adding these both will not be difficult. 5 m VCM square by 6. Small, silly, but an important thing.
सर
हाँ,
विस्कस होता मतलब तो फिर वो उसमें रोटेशनल भी होता ना.
partly. It will not be a perfect rotating body. There will be some angular velocity for the liquid. May not be angular velocity. Linear velocities will be different. Viscous liquid may problem is one layer and the adjacent layer don't move with the same speed. So
do we have
not
this?
the angular velocity, but linear velocity of all the layers also need not be the same.
So once we do fluid dynamics, will we have questions like this that come?
In fact, in fluid dynamics, you will understand the significance of non-viscous liquid. If it were viscous, how will it flow will be understood.
Done, sir.
Just a
Sorry.
yes, sir. Done.
No. Condition for rolling, have a look at it. This is VCM omega. Before I start any problem, you are told translational dynamic equation, rotational dynamic equation, and constraints, right?
Yes.
Yes.
Now to write the translational and rotational dynamic equation, I should know if friction is acting and in which direction.
Yes, sir.
So first of all, friction acts on the point of contact. Friction acts on the point of contact.
Yes.
Right?
Yes, sir. Yes.
This will be R omega.
Friction in the
minus r omega plus BCM is velocity of point of contact with respect to ground. Velocity of the point of contact with respect to center of mass plus velocity of center of mass with respect to ground is the velocity of the point of contact with respect to ground.
Yes, sir.
Yes,
yes,
sir.
Case 1. If VCM is greater than R, if VCM is greater than R, VCM is greater than R, point of contact is slipping in the forward direction. Slipping in forward direction. Because VCM is greater than R omega, this turns out to be positive. That means point of contact has got velocity. It's slipping in the forward direction. Friction acts in backward direction. Agree?
Yes.
Yes.
yes, sir.
Case 2. If R omega is greater than VCM, R omega is greater than VCM. That means point of contact is slipping in
Backward
direction.
direction.
Point of contact is slipping in backward direction. Friction acts in
Forward direction.
direction. Case 3.
V is equals to R omega.
VCM is equal to R omega.
At rest with respect to
At
This
friction
condition is called rolling. What is this condition called as? Rolling.
Rolling.
Without slipping. So point of contact is at rest with respect to surface.
yes, sir.
No.
No
Friction
friction.
may be acting either in the forward direction or in the backward direction. We don't know. It
Yes,
depends on the problem.
Yes, sir.
क्या बोल रहे हो यार? Why will it depend on the problem? I am standing this way. My feet are at rest with respect to ground.
Yes, sir.
My feet are at rest with respect to ground. You are pushing from behind. I am yet at rest. Friction is acting in backward direction.
Backward direction.
You come to the front and you are pushing from ahead. I am at rest. No, friction is acting in
Forward
forward
direction.
direction.
Forward.
So that will depend on the problem. I cannot give you a general rule. So procedure to be followed is, if point of contact is at rest and the body is rolling, assume a direction of friction. Assume a direction of friction. Solve the problem. Solve the problem. Assume a direction of friction. Solve the problem. If friction turns out to be positive, direction taken is correct. Direction is correct. If friction turns out to be negative, direction taken is wrong. Reverse the direction.
Opposite direction.
Yes.
Right? So if the body is rolling, assume a particular direction for friction. If the direction of friction taken is correct, you will get positive. One more very important point. When the body is rolling, friction is compulsorily less than or equal to mu. Why? Because the body is toppling. Toppling means point of contact is at rest. If it is at rest, friction can be any value between 0 to mu.
yes, sir.
Central mass may be going ahead. So friction ka necessary condition, rolling ka necessary condition is VCM equal to R omega. Sufficient condition is friction should be less than or equal to mu.
Yes,
Rolling ka necessary condition, VCM is equal to R omega. Point of contact is at rest with respect to the surface. Sufficient condition, friction is less than or equal to mu. So this friction will be a variable. Whenever body is rolling, keep one thing in mind. Don't take friction as mu. It can be anywhere between 0 to mu. It is toppling.
So in case 1 and case 2, it will be mu1, right?
Case 1 and case 2 friction is mu n because the point is slipping.
So can you again explain why friction acts in the third case?
Friction may either be in the forward or backward direction. That depends on the problem. So assume a direction of friction and solve the problem. If you get it to be positive, direction taken is correct. Negative, reverse the direction. But most importantly, remember friction will not be mu n. It will be anywhere between 0 to mu n. Right?
Yes, sir.
In the first two cases, friction will be mu n. Point of contact is slipping.
So, but in the third case, if there's no relative motion, why will friction act?
I am at rest. Somebody is pushing me from behind.
Okay, sir.
A block is on ground, you are applying force, block is not moving. Do you have friction?
Yes, sir.
Can I rub the board?
Yes, sir.
Yes, sir.
Yes.
Now the tricky situation is on an inclined plane. on an inclined plane. How do you go about with an inclined plane? Inclined. Listen to the analysis. To solve the problem, I should know the direction of friction. Yes or no?
Yes, sir.
Yes, sir.
Body rolling down an incline. Body rolling down an incline. Now here, have a look at it. You know the condition VCM equal to R omega is the condition for rolling. Yes or no?
Yes, sir.
We'll slightly go one step ahead and make our life a bit simple. You will differentiate this. Differentiation of VCM with respect to T is R d omega by dt. A is equal to R.
Yes, sir.
We are okay with it. But remember one thing here. If this is A and this is alpha, this is R alpha. Minus R alpha plus A is 0, that means A is equal to R. This is what we are explaining. Now here they play with words. For rolling, what is the fundamental condition? Point of contact should be at rest with respect to the surface. Only then I will get VCM minus R omega 0.
Yes,
Yes,
sir.
sir.
Now that I differentiated and I got this. So I can tell you velocity of the point of contact is 0, but when I tell you acceleration, seeing this, don't jump to conclusion. This is only tangential acceleration. R alpha is what? Tangential acceleration, not
Yes, sir.
centripetal. When a particle is going in a circular track, it has only one velocity. But it has two.
Acceleration.
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 Here you are equating which acceleration to 0?
Tangential.
Tangential acceleration.
Not
Tangential.
centripetal. The lowermost point does have a centripetal acceleration towards the center.
Yes.
Lowermost point does have a centripetal acceleration towards the center. Do you get that clear?
Yes, sir. So,
So remember, when you are equating A minus R alpha to 0, you are equating tangential acceleration to 0. They play with words. They give you assertion and reason statements stating that acceleration of the lowermost point is 0 when it is rolling. Students are tempted for yes. Only tangential acceleration is 0. Centripetal is not 0. Now, listen. I'm interested in the direction of friction on this body when it is rolling down. Listen to the analysis carefully. It will be quite heavy. Quite heavy. Can I claim ACM is in the downward direction? ACM is down the incline. Keep saying something, yes or no.
yes.
ACM plus R alpha is the tangential acceleration of point of contact. This should be 0, implies ACM and R alpha should be in opposite direction. ACM and R alpha must be in opposite direction. Implies R alpha is up the incline. Do you all agree with that?
Yes, sir.
Yes.
So R alpha must be up the incline. Implies alpha must be in anti-clockwise direction. Anti-clockwise direction. Agreed?
Yes, sir.
Yes, sir.
Only friction produces a torque here. Produces a torque in this case. क्यों भाई साहब? Why only friction produces a torque? Mg is passing through the center of mass. Normal force is passing through the center of mass. Other than friction, is there any other force which can produce a torque?
No. No, sir.
Now, and that torque must be in anti-clockwise direction. Alpha must be in anti-clockwise means torque must be in anti-clockwise.
Yes, sir.
Yes, sir. I alpha.
And friction must act up the incline to produce anti-clockwise torque. Friction acts up the incline to produce an anti-clockwise torque. Anti-clockwise torque. Friction acts up the incline to produce an anti-clockwise torque. Right?
Yes, sir.
Take it down till here. Clear up the board.
Yes, sir.
Yes.
Now listen to one important key analysis here. Till now, rolling according to you was VCM equal to R omega,
Yes, sir.
Yes.
right?
Sir.
VCM equal to R omega. All of a sudden, you started using acceleration. All of a sudden, you started using acceleration, right?
Yes.
Can you explain this analysis using velocity only? I'll be more than happy. Can you explain this analysis of friction using velocity? Point of contact is at rest is fundamental requirement, right?
Yes.
Yes, sir.
Yes,
So
sir.
have a look at it. The body has VCM downwards. R omega should be up the incline. Only then velocity of point of contact is at rest.
Yes, sir.
VCM is down the incline. Down the incline. VCM is down the incline. R omega is up the incline. Agreed?
Yes, sir.
Only then VCM minus R omega can be 0. Only if they are in opposite directions,
Yes, sir.
right? R omega is up the incline. So what does omega mean? 1 second, I'll be back in a second. Right. R omega is up the incline. VCM minus R omega is 0. R omega is up the incline. Now have a look at it. For this relation, VCM equal to R omega to sustain. This should sustain.
Yes,
Yes, sir.
As the body is going down, VCM is increasing. Do you agree with that?
Yes.
Yes,
Yes,
sir.
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 Omega must increase.
Yes, sir.
Yes, sir.
Omega must increase. Alpha must be in the direction of omega. In the direction of omega. Only then omega will increase.
Yes,
Torque
sir.
must be in the direction of omega. That means
Alpha,
torque
sir.
is in anti-clockwise direction. Torque is in anti-clockwise direction. Right?
Yes, sir.
Yes.
Torque is in anti-clockwise direction implies friction alone produces torque, hence friction is up the incline. This point should be at rest. So VCM is equal to R omega should sustain. As the body is rolling down, VCM is increasing, hence omega must increase.
Yes, sir.
Omega must increase, acceleration, angular acceleration alpha must be in the same direction as that of omega. Right? Torque must be in the direction of alpha, rather omega. That means torque is in anti-clockwise direction. Torque is in anti-clockwise direction implies friction alone produces torque. Hence friction must be up the incline.
Yes.
Is the complete analysis clear?
Yes, sir.
Yes.
Yes, sir.
The next analysis will be when the body is rolling up. Both the situations, you are not applying any external force. Body is rolling on its own. Next analysis is body is rolling up the incline. I set it into rolling. Take it down till here, I'll explain.
Sir, I had a doubt.
Hmm.
Sir, in case 3, when we wrote that f should be less than equal to mu n, it should also be greater than 0, right? Because it should produce a torque.
Actually,
है ना? Yes, okay, sir. Got it. Thank you.
So, but most probably if we have class on Monday, it will be with you only because generally Mondays are kept for rotation.
Okay, great. Then we'll be finishing off this concept that is partly safe for us.
So in the offline session, batches will be preserved, right? Like Zenith 1 will remain as Zenith 1, right?
Zenith 1 will remain as Zenith 1. The students and it will slightly change.
Okay, so.
No, you're from Andheri, right? There are some students from Chembur or say Nerul. They will not be in your class.
No, sir, I'm saying like for them, they'll also be in a batch, right? In their offline center. So for them, their batch will be like, it will be from this Zenith 1 batch only, right? A subset of that.
Generally, no. Generally, how we nomenclate them is we should know that they are from Chembur. We should know from they are from Nerul. So generally, previously we used to name them as
OAPJC.
old APJC 1, that means Andheri student. Old CPJC 1, that means Chembur students. Old NPJC 1, matlab Nerul student. So we should know which center they are from.
And so what about shuffling of batches?
अभी ये session itself, this adjustment of timetable itself is a huge pain. इसमें फिर shuffling थोड़ी करेंगे, shuffling थोड़ी बाद में देखेंगे, तब तक syllabus हो.
हाँ सर ठीक है फिर अच्छे.
अच्छा सर वो बहुत ज्यादा
हाँ सर सफलिंग उसके बाद चलेगा.
एडवांटेज तो हो गया ऑफलाइन.
हाँ सर नहीं तो फिर अंधेरी में रहते रहते टीचर्स अलग हो जाते तो मतलब.
सर एक्चुअली वो एडवांटेज रहता ना,
वो
एडवांटेज रहता था ना कि फर्स्ट बैच में हमेशा रहना चाहिए तो उतनी ज्यादा
कुछ खास नहीं. And trend will be the same. Now this concept first batch के लिए में friction upward, second batch के लिए friction downwards थोड़ी पढ़ा.
तो लेकिन आप पढ़ा रहे हो ना वो.
हाँ सर वो
हाँ सर टीचर्स का फर्क पड़ेगा.
नहीं, अंधेरी में it will be the same.
अच्छा सर ठीक है.
सर ये हो गया.
यस सर
Done.
Done, sir.
Now body rolling up an incline. Using acceleration, my job becomes very, very easy. Body rolling up an incline. Body rolling up an incline. क्या फर्क पड़ता है? Even if it is rolling up, even if it is rolling up, it is decelerating upwards. Rolling up, decelerating up the incline. Am I right?
Yes, sir.
That means it is accelerating down the incline. That means accelerating down the incline. Agreed?
Yes, sir.
Analysis will be the same. That means R alpha is up the incline. It is rolling up, but it is decelerating. Decelerating. That means it is accelerating downwards. Accelerating downwards means R alpha should be upwards. That means alpha must be in anti-clockwise direction.
Yes, sir.
Alpha must be in anti-clockwise direction. Alpha is anti-clockwise. Torque must be in anti-clockwise direction. Friction is up the incline. क्या बोल रहे हो यार? Whether the body is rolling down or rolling up, friction will always be up the incline. When the body is rolling down, you told me friction is up the incline. Body is rolling up, friction is again up the incline. Beautiful, right?
सर ये तब है
Yes,
ना
sir.
तब दो एक्सटर्नल फोर्स.
Yeah, there is no external force.
I have a doubt.
That's why I am assuming A is rolling down. So I just kept a body on an inclined plane and I am making it roll.
Sir, R alpha is up the incline because it's decelerating, right?
R alpha is up the incline because tangential acceleration of this point should be 0.
Yes, sir.
Point
So
of contact is at
ACM
rest.
plus R alpha should be 0.
Yes, sir.
So I have a doubt.
ACM plus R alpha vector summation should be 0. That means ACM is equal to minus R alpha. That means ACM is downwards, R alpha is upwards.
Yes, sir. Got it.
So in this case, VCM would be up the incline, right?
I'll explain even using VCM. And
So but then
you will get
R omega will be down.
I said I will explain my यार.
Okay, sorry, sir.
अभी explain नहीं करूँगा तो you ask it makes sense. I'll explain बोल रहा हूँ.
Answer.
So wait. That's
Now listen. Rolling up. Rolling up. So VCM is upwards.
Yes, sir.
Body is rolling up. Now I will not explain using deceleration. It's rolling up. VCM is upwards. So for the body to roll, R omega should be down the incline. VCM is up the incline. Agreed?
Yes, sir.
R omega must be down the incline. R omega is down the incline implies omega is clockwise. Do you agree with that?
Yes, sir.
Now VCM equal to R omega relation should sustain for rolling. Agreed?
Yes, sir.
Yes, sir.
Here, as the body is rolling up, VCM is decreasing. Do you agree with that?
Yes.
Omega must decrease. If this relation should sustain, VCM decreases, omega must decrease. If omega must decrease, alpha must be
anti-clockwise direction.
in anti-clockwise direction. Alpha must be in anti-clockwise direction, torque must be in anti-clockwise direction. Friction alone produces torque, which implies friction acts up the incline. So the beauty in whole of this analysis is, without the help of an external force, if the body is rolling, either down the incline or up the incline, friction will be always acting
Up the incline.
Incline.
up the incline plane. Without the help of an external force, most important word, If the body is rolling either down the incline or up the incline, either of the two situations, friction will be acting up the
Upward.
incline. Your class notes is your only reference for this complete analysis. Don't miss out on this.
So done.
Done, sir.
Now that I know the direction of friction for a body rolling down an inclined plane, I am interested to know the expression for acceleration, velocity, so on. Body rolling down an inclined plane, body rolling down an incline. I need a general expression. This is a standard derivation in the theory, right from your HSC textbook till IIT. History of IIT entrance examination, they have never ever asked a standard derivation, except for this 2004 G. Derive an expression for a body rolling down an inclined plane. Derive an expression of a body rolling down an inclined plane. Standard derivation has never been asked in IIT except for this. Before I can go into this, I need to explain a small word called radius of gyration. Radius of gyration. Nothing very significant, just a general form. What do you mean by radius of gyration? Listen. That point at which whole of the mass appears to be concentrated, that point at which whole of the mass appears to be concentrated when the body is rotating about this axis. Distance of that point from the axis of rotation is called radius of gyration. Distance of that point at which whole of the mass appears to be concentrated. Distance of this point from the axis of rotation is called radius of gyration. Center of mass की तो है नहीं?
Yes, sir.
नहीं है सेंटर ऑफ मास. ऐसा एक्सिस चेंज करोगे तो रेडियस ऑफ गायरेशन चेंज हो जाए.
Yes.
एक्सिस सेंटर ऑफ मास चेंज नहीं होगा, मगर एक्सिस चेंज करोगे तो पॉइंट एट विच होल ऑफ द मास appears to be concentrated changes as far as the radius of gyration is concerned. How will you calculate this? पहले क्यों नहीं बताया? मोमेंट ऑफ इनर्शिया करते वक्त क्यों नहीं बताया? Not very significant. Have a look. So moment of inertia of a body in general is mk square. K is distance of that point from the axis of rotation at which whole of the mass appears to be concentrated for that particular axis of rotation. Have a look. Thin rod ml square by 12 is equal to mk square. K turns out to be plus or minus L by 12. Suppose the same thin rod is rotating about this, ml square by 3 is mk square. K is plus or minus L by root 3. Ring mr square is equal to mk square. K is equal to r. Disk mr square by 2 is equal to mk square. K is equal to plus or minus r by root 2. Hollow sphere, K is plus or minus 2 by 3r. None of these distances are from center of mass. Ring का देख लो आप, center of mass is here. So if you interpret that as center of mass, radius of gyration should be 0.
Yes, sir.
Yes, sir.
Right? There it is plus or minus r.
Yes, sir.
Yes.
K is a general symbol used to represent any arbitrary body. How do you want me to find out K? There is no special procedure. Find out moment of inertia, equate it to mk square. There is no special procedure. Moment of inertia, equate it to mk square, you will get K. First write down the radius of gyration.
सर
हाँ,
सर मतलब ये क्या है वो समझा नहीं मुझे, मतलब ऐसा विजुअलाइज नहीं हो रहा है डायरेक्शन का रेडियस.
करने की जरूरत है नहीं.
अच्छा.
Just equate mk square to
I.
that's it.
Moment of
So K is, it is like telling you whole of this mass I'll remove, place it here at a distance of K. What is the moment of inertia mk? पूरा mass of the body निकाल के यहाँ पर रख दो. Moment of inertia is mk. Distance of that point for a thin rod, if I remove whole of the thin rod and place the mass at a distance of L by root 12, what will be the moment of inertia? ml square by 12?
Yes, sir.
So it is equivalent to replacing whole of that body with a point mass at that particular point.
Could you repeat the statement for it?
Distance of that point from the axis of rotation, distance of that point from the axis of rotation at which distance of that point from the axis of rotation at which whole of the mass appears to be concentrated, at which whole of the mass appears to be concentrated for that particular axis of rotation. For that particular axis of rotation.
Sir, this point, the mass is concentrated when the body is rotating, na, at this point.
Naturally, if the body is not rotating, moment of inertia का क्या करूँ मैं? Body is at rest. इसका moment of inertia लेकर करूँ क्या मैं?
So mk square equals to IC plus mt square only, na?
नहीं, mk square is the moment of inertia. ml square by 12 equated to mk square. You get k. That means you can replace whole of the rod mass as a point object at this particular distance.
That's how God.
Similarly, whole of the mass of this body, I keep it here. Moment of inertia is mk square. As far as this is concerned, whole of the mass of the rod, I'll keep it at a distance of L by root 3. L by root 3. What will be the moment of inertia? ml square by 3. It is replacing whole of the body with a point mass at a particular point. Distance of that point from the axis of rotation is radius of gyration.
Sir? Sir, the assignment which you have sent, you will be discussing on Monday, or we'll discuss with center faculties, which will on off or offline.
Monday we have in labs, I will discuss that. Sunday आपके topic wise test खत्म होते ही बैठ के वो assignment solve कर.
हाँ सर, ओके सर.
वो ऑलमोस्ट खत्म ही हो गया. फिर उसके बाद आप असाइनमेंट भेजोगे कि फिर नहीं होगा?
उसके बाद
तो उसके बाद आप
I didn't get you.
So will you be sending other assignments after this one?
What kind of a question is this? Why did you ask that question? What is it that you want to ask? I don't understand this.
So he's saying for people who will be going in offline, who won't have you as their regular teacher, he's requesting you to
whoever is covering that, they will send as I give you the assignment. Yeah.
Okay, sir.
By chance you didn't get, you want these assignments, leave a message on the WhatsApp group, I'll forward it to you.
Yes.
Okay, sir. Thank you. We're done. Done, sir.
Now, listen. Body rolling down an incline. Free body diagram पहले draw कर लो. This will be mg sin theta. This will be friction. Perpendicular to the inclined plane, I am not interested in. So the translational dynamic equation, rotational dynamic equation, constraint relations. Agreed?
Yes.
Yes, sir.
mg sin theta minus friction is m into a. Friction, why did you take it up the incline? We just know analyze the four possible ways that friction will be up the incline when the body is rolling down. Second, body is rolling, so friction will be less than
mu n
or equal to mu n.
less than equal to mu n.
Less than or equal to mu n. Need not be mu n.
Yes.
I don't know the value of friction. I'll have to solve for it.
Yes, sir.
Second, rotational dynamic equation. Talk about COM is F into R is equal to I into R.
Yes.
F into R, I you will write the general formula mk square. Mk square is the general formula for any body.
Yes.
Yes, sir.
You tell me hollow sphere. Instead of mk square, I'll put 2 by 5 mr, 2 by 3 mr square. Solid sphere, 2 by 5 mr square. So this is my second equation. Mk square by R into alpha. Translational dynamic equation, rotational dynamic equation. Constraints. I will draw the diagram again. So that it's clear. ACM is down the incline. किसने बोला भाई साहब आपको ACM is down the incline बोल के? आपके इक्वेशन ने बोला है.
Yes.
You make a choice right in the start. After that, you will stick to it. Right? You make a choice right in the start. After that, you will stick to it. Fine. You didn't write friction minus mg sin theta, right? You're writing mg sin theta minus friction is mass into acceleration. Fine. You didn't write friction minus mg sin theta. You're writing mg sin theta minus friction is mass into acceleration. That means A is down the incline. Your torque equation is F into R. That means alpha is anti-clockwise. So R alpha is up the incline. So A minus R alpha is 0. Alpha is A by R. This is 3.
Yes.
Substitute this alpha here. Substitute this friction here. Mg sin theta minus friction is mk square by R
Into A.
into alpha. Alpha is A by R.
Yes, sir.
This will be equal to ME. See what I have done. I substituted alpha here and substituted this friction here. Are you people okay with that?
Yes, sir.
Yes.
G sin theta is 1 plus k square by r square into A. A is G sin theta upon 1 plus k square by r square. Acceleration of a body rolling down an inclined plane is a standard derivation for you people right from your HSC syllabus. In your college 12th board examination, this is a guarantee question. 3 marks derivation for acceleration of a body rolling down an inclined plane. 2004 JEE, they asked you to derive this acceleration in a subjective paper for 4 marks. Now you understand how important the derivation is?
Yes.
Now, how do you want me to ascertain k square by r square? For a ring, mk square will be equal to mr square. How much is k square by r square?
1.
Yes, mk square is equal to mr square by 2. How much is k square by r square?
1 by
Half.
Hollow sphere, mk square is 2 by 3 mr square. How much is k square by r square?
2 by 3.
2 by 3.
Solid sphere k square by r square is
2 by 5.
2 by 5.
They will give you objectives where they will ask, which among the following bodies have got greater acceleration down the incline? Mass is not there in the picture.
Ring.
There is no mass. More massivity, more acceleration. Ille. कितना मास ले लो मुझे कुछ लेना देना ही नहीं. Depends on the shape of the body. Among the four, ring का k square by r square is maximum. Ring का k square
So acceleration.
greater the k square by r square.
Lesser the acceleration.
Lesser the
Smaller the acceleration.
That's
Greater
acceleration.
the k square by r square, greater the acceleration. You can arrange an inequality for all of them.
Yes, sir.
Yes.
Now then they'll ask you for velocity. Right?
Yes.
I'll derive an expression for velocity as well. Take it down till here.
Sir,
Hmm.
sir, can you repeat what you were saying about the mass? It is independent. The question I meant.
समझा नहीं मैंने.
सर जो आप बोल रहे थे ना कि ये जो टर्म है वो इंडिपेंडेंट है मास का, तो क्वेश्चन क्या था सर? कैन यू रिपीट दैट?
Acceleration of the body, they are comparing which will have greater acceleration.
सर तो
Ring will have greater acceleration, or disk will have, hollow sphere or solid sphere. Which among them will have greater or lesser accelerations? That's independent of mass. It depends on the ratio of k square by r. In the expression for acceleration, do you have mass?
No, sir.
That's it. This distance is yes, right?
Yes, sir.
Yes.
So what will this height be, h? V square is u square plus 2a, 2 into what is acceleration? G sine theta upon 1 plus k square by r square. Yes or no?
Yes, sir.
Yes, sir.
Can you recognize s sine theta as h?
Yes, sir.
1 plus k square by r square. Under root 2g h upon 1 plus k square by r square. I'll give you 4 bodies. Ring, disk, hollow sphere, solid sphere. Which will have maximum velocity when it comes to the lower bottom? The one with least k square by r square?
Yes, sir.
Solid sphere.
Which among them has the least k square by r square? Solid
Solid
sphere?
sphere.
Solid
Yes, sir.
Comparing between the other three, this is 0.6, this is 0.5, this is 1.
0.4.
0.4 give us
0.4.
0.6. Sorry, 0.5.
Yes.
Disk. Solid sphere will have the maximum velocity. Disk the second. Hollow sphere the third. Ring will have the least velocity. Is that clear?
Yes, sir.
Can I rub the right hand side part of the board?
Yes, sir.
So one sec. Right hand side, yes.
HCV plays practical jokes with you people. 1 minute ध्यान से सुनिए. Why the author HCV is that great? 2 objectives he will give you: comparison of accelerations, comparisons of velocities. So जोर लगा के है k square by r square values लेके आप solve करेंगे, you will get the answer. That next bit you will not get the answer. You turn the page and see, he will tell you all of them acquire the same velocity. Then again you turn back and see, in the next bit he gave you the inclined plane to be smooth. When the inclined plane is smooth, there is no friction, there is no torque. Yes or no?
Yes, sir. Yes, sir.
Body will have no rotational motion on the incline. It will be pure translation.
Yes, sir.
All will have the same velocity. Because acceleration is g sin theta for all three.
हाँ सर.
Yes, sir.
आई बात समझ में? So keep your eyes open when you are solving the objectives. This analysis will hold good if and only if the body is
Rotation.
Rolling.
Pure rotation.
Rolling.
If the body is
rolling.
Rolling.
if it is not rolling, do not use this analysis.
Yes.
Now listen to me 1 second. Even if you have not completed writing this, listen to me. When the body is rolling, what did you tell me? Do I have all your attention? Something important is
Yes,
being told.
Yes.
Sir.
When the body is rolling, point of contact is at
Rest with
Yes.
respect.
With respect to
With
surface.
respect to the surface.
so work done by friction will be
Zero.
Zero.
work done by friction is
Zero.
Zero.
so loss in potential energy should be gain in kinetic energy.
Kinetic energy. Yes,
Yes.
sir.
VOC is at rest. VOC is at rest. Work done by friction is zero. If work done by friction is zero, loss in potential energy mgh is half mv square half ICM omega. Kinetic energy of the body rolling down an inclined plane.
Yes, sir.
Yes.
Half mv square plus half ICM. What is ICM? mk square. What is omega square v square by r?
Square by
Why is omega v by r?
Rolling.
Rolling. Right? And general formula for moment of inertia mk square. 2mgh is equal to mv square plus mv square mv square into 1 plus k square by r square. I brought 2 to the numerator of the left hand side and I took mv square common. V is root over of 2gh upon 1 plus k square by r.
Same.
Whole of mechanics which we have studied till now is revised. Translational, first you calculated velocity using what? V square is equal to u square plus 2as.
Yes, sir.
Yes, sir.
Did you get that acceleration? Translational dynamic equation, rotational dynamic equation, constraints.
Yes.
Conservation of energy.
Yes. सर सारे मैकेनिक्स के चैप्टर आ
That's the reason why rotational dynamics becomes big. It is an application of all concepts of mechanics that we have learned.
सर आपने ये सब खुद को ही सिखाया था ना while you were preparing?
Yeah, our times we didn't have coaching industry. We had
Sir, hats
have
off.
a hell of a time learning all this.
खतरनाक है यार.
And YouTube भी था नहीं, internet था ही नहीं. So Halliday Resnick was the only source. Doubt आया तो उसमें Halliday Resnick में keep digging. The hint will come to you, from there you survive. Books also we didn't have so many those times. It was only Halliday Resnick which explained the concept, or Berkeley series, and we couldn't afford Berkeley series then. Cost of the complete series of Berkeley series 3 volumes was those days 2,200. Just imagine 1987.
सर
हाँ
सर यूट्यूब पे एक वीडियो था जिधर 2 बॉल्स एक ऐसा एक स्ट्रेट ट्रैक पे रिलीज हो रहा है और एक कर्वी ट्रैक पे रिलीज हो रहा है और दोनों आइडेंटिकल बॉल्स है बट बोथ रीच द एंड पॉइंट एट द सेम टाइम. सर हाउ?
You mean?
So he's saying there's one path which has a lot of, it's like an inclined plane only, but it's got a lot of curves along its surface. And then there's another, and then there's just a straight inclined plane. And then from the topmost point of both, 2 balls are released simultaneously. But the ball on that curvy wala inclined plane.
About this, if there is a bead which slides in this and this, both will reach simultaneously.
No. So make two inclined planes, two separate inclined
सर
planes.
मैं आपको वीडियो
Wait.
भेजूं?
Wait. Send the video. I'll see that. Then it will become easy. I want to show you
Okay.
people in another video by then. Wait. I am also searching for a video which I don't know if this would suffice.